find IE, VE, VB, VC, and the overall voltage gain, which is VO over VI, assuming that IC is equal to IE. So first is we are going to determine the DC equivalent of the circuit. So our R1 is 47.47 k ohms, R2 is 10 k ohms, RC is 4.7 k ohms, our VCC is positive 10 volts, VDC is 150, RE sub 1 is 470 ohms, RE sub 2 is 470 ohms. So the solution for this is we must first find RTH and VTH so that we can get the answers for IE, VE, VB, VC, and the overall voltage gain. So we have here RTH. The formula for RTH is R1 multiplied by R2 over R1 plus R2. So our R1 is 47 k ohms. So 47 k ohms multiplied by R2, which is 10 k ohms, over 47 k ohms plus 10 k ohms. So RTH is equal to 8.25 k ohms. Next is to find VTH. The formula for VTH is R2 over R1 plus R2 multiplied by VCC. So R2 is 10 k ohms, R1 is 47 k ohms plus 10 k ohms, and our VCC is 10 volts. So the answer for VTH is 1.75 volts. Now we can already get the answer for IE. The formula for RE is VTH minus VBE over RE plus RTH divided by VDC. So VTH is 1.75 volts. We inputted VTH here and it is minus by 0.7 volts because we already know that VBE is as is and it cannot be changed. So 0.7 volts cannot be changed. Then RE, we added RE sub 1 plus RE sub 2, 470 plus 470, which is equal to 940 ohms. Then our RTH is 8.25 k ohms divided by VDC, which is 150. So the answer for RTH divided by VDC is 55 ohms. So 1.75 volts minus 0.7 volts over 940 ohms plus 55 ohms. So the answer for IE is 1.06 mA. So we assume that IC is equivalent to IE. So our IE is 1.06 mA. So our IC is 1.06 mA. Next is to find VE. The formula for VE is IE multiplied by RE sub 1 plus RE sub 2. So our IE is 1.06 mA multiplied by RE sub 1, which is 470 plus 470, which is equal to 940 ohms. So 1.06 mA multiplied by 940 ohms is equal to 1 volt. So VE is equal to 1 volts. Next is to solve for VB. The formula for VB is VE plus VBE. So our VE is 1 volts and VBE is 0.7 volts. So the answer for VB is 1.7 volts. Next is VC. The formula for VC is VCC minus IC multiplied by RC. So VCC is 10 volts minus IC because we let IC as an equivalent of IE, which is 1.06 mA. So minus 1.06 mA, and our RC here is 4.7 k ohms. So 1.06 mA multiplied by 4.7 k ohms. The answer for VC is 5.02 volts. Next is to find the overall voltage gain, which is VO over VI. So we all know that AV is equal to VO over VI. So the formula for this is IE multiplied by RE over IE multiplied by R1E plus RE. So IE is 1.06 mA, RE is 940 ohms, IE is 1.06 mA, but we didn't get the answer for R1E. So we are just going to leave it blank and we will solve it after we get the answer for AC equivalent of the circuit. Next is to find the AC equivalent of the circuit. So we must first determine the circuit. So RS is 600 ohms, VS is 10 MV, R1 parallel with R2 is 8.25 k ohms, BAC is 175, RE sub 1 is 470, and we have a formula here of RC, which is RC multiplied by RL over RC plus RL. So the first thing to do in the AC analysis is calculate R1E. So here R1E is equal to 25 MV over IE. Our IE is 1.06 mA, so 25 divided by 1.06 mA is 23.6 ohms. So our RE is R1E is 23.6 ohms. Here, we didn't get the answer for VO over VI. So we can now input the value for R1E, which is 23.6. So our AV, which is equal to VO over VI, is equal to 0.98. So now, the DC equivalent of the circuit already got the answers. So for IE, we have 1.06 mA. For VE, we have 1 volts. For VB, we have 1.7 volts. For VC, we have 5.02 volts. And our VO over VI or AV is 0.98. So here are the answers for the DC equivalent of the circuit. Now, we will continue to the AC equivalent of the circuit. So next is to determine the attenuation in the base circuit. Looking from the 600 ohms source, the total of RIN is, so we have here, RIN is equal to R1 parallel with R2 parallel with R in base. So R in base is equal to BAC multiplied by R1E plus RE sub 1. So BAC is 1.175, our R1E is 23.6, and our RE sub 1 is 470. So the answer for R in base is 86.5 k ohms. So therefore, I in is equal to 47 k ohms parallel with 10 k ohms parallel with 86.5 k ohms. The answer will be 7.53 k ohms. So the attenuation from the source to base is equal to attenuation equals Vs over Vb, which is equal to Rs plus Rin over Rin. So input the values for the given formula. So 600 ohms plus 7.53 k ohms over 7.53 k ohms. So the attenuation is 1.08. So before AV can be determined, we must know the AC collector resistance, which is RC. So the formula for RC is RC multiplied by RL over RC plus RL. So input the given formulas. So 4.7 k ohms multiplied by 47 k ohms over 4.7 k ohms plus 47 k ohms. So the answer for RC is 4.27 k ohms. So the voltage gain from base to collector is AV, which is equal to RC over RE sub 1. So our RC is 4.27 k ohms over 470 ohms. So our AV is 9.09. The overall voltage gain is the reciprocal of the attenuation times the amplifier voltage gain. So the formula is A1V equals VB over VS multiplied by AV. So 0.93 multiplied by 9.09, A1V is 8.45. The source produces 10 MV RMS. So the RMS voltage at the collector is VC equals A1V multiplied by VS. So 8.45 multiplied by 10 MV. So the answer for VC is 84.5 MV. So we already got the answer. So find first the attenuation from source to base brought by RS. So the attenuation answer is 1.08. Next is to find the voltage gain from base to collector. So the answer is, which is AV, 9.09. Then finally, the overall voltage gain is the reciprocal of the attenuation times the amplifier voltage gain. So the answer for that is, which is VC, which is equal to 84.5 MV.